Welcome back to Java Internals Crashcasts. I'm your host Sheila, and today we're continuing our deep dive into the world of concurrent collections. We're in the third season, focusing on concurrent collections, and we're wrapping up our chapter on deques.
That's right, Sheila. In our previous episode, we covered the BlockingDeque interface, and now we're going to explore its concrete implementation, linked BlockingDeque. This is an exciting topic that combines the power of linked structures with concurrent programming.
Before we dive in, let's start with a quiz question for our listeners. Here's the question. In what scenario would you choose linked BlockingDeque over array BlockingDeque? Think about it, and we'll reveal the answer at the end of the episode.
That's an excellent question, Sheila. It really makes you think about the underlying structures and their performance characteristics. I'm sure our listeners will come up with some interesting theories.
Now, Victor, can you give us a brief overview of what linked BlockingDeque is and why it's important in the world of concurrent programming?
Certainly. Linked BlockingDeque is a concurrent implementation of the Deque interface that uses a linked list as its underlying data structure. It's thread-safe and supports operations from both ends of the Deque. The blocking part of its name comes from its ability to block threads when the Deque is empty or full, depending on the operation.
That's interesting. So it's like a double-ended queue that can handle multiple threads safely. Can you explain how it achieves thread safety?
Great question. Linked BlockingDeque uses a combination of locks and conditions to ensure thread safety. It has a single reentrant lock, which is a type of lock that can be repeatedly acquired by the same thread, to protect the entire structure. It also has two condition objects, one for signaling when the Deque becomes non-empty and another for when it becomes non-full. This allows for fine-grained control over thread blocking and waking.
I see. So it's like a well-coordinated dance of threads with the lock acting as the choreographer. Can you give us an analogy to help visualize how linked BlockingDeque works?
Absolutely. Think of linked BlockingDeque as a double-ended assembly line in a factory. Workers can add or remove items from either end of the line. The reentrant lock is like the factory manager, ensuring that only one worker can modify the line at a time. The condition objects are like signal lights. Green means go ahead, the line has space, or go ahead, there are items to process, while red means wait, the line is full, or wait, there are no items yet.
That's a helpful analogy, Victor. Now let's dive a bit deeper. How does the linked list structure of linked BlockingDeque affect its performance compared to array-based implementations?
Great question. The linked list structure gives linked BlockingDeque some unique characteristics. Unlike array-based implementations, it doesn't have a fixed capacity by default, which means it can grow as needed, unless you specify a capacity when creating it. This makes it more flexible for scenarios where you don't know the maximum size in advance.
That sounds useful. But doesn't that unlimited growth potential come with some drawbacks?
You're absolutely right to question that, Sheila. While the ability to grow indefinitely can be an advantage, it also means that linked BlockingDeque can potentially consume a lot of memory if not managed properly. Each element in the Deque is wrapped in a node object, which adds some overhead compared to storing elements directly in an array.
I see. So it's a trade-off between flexibility and memory efficiency. Are there any scenarios where linked BlockingDeque really shines?
Definitely. Linked BlockingDeque is particularly useful in producer-consumer scenarios, where you need to add or remove elements from both ends of the Deque. For example, imagine a task scheduling system where high-priority tasks are added to the front of the queue, while normal tasks are added to the end. Consumers can then efficiently process tasks from either end based on priority.
That's a great real-world example. Now, let's talk about some common pitfalls or misunderstandings developers might have when using linked BlockingDeque. What should our listeners be aware of?
One common misunderstanding is assuming that because linked BlockingDeque is thread-safe, you don't need to worry about concurrency issues at all. While it handles internal synchronization, you still need to be careful about how you use it in your overall application design. For example, if you need to perform multiple operations atomically, you might need additional synchronization.
That's an important point. Any tips or best practices for using LinkedBlockingDeque effectively?
Absolutely. First, consider specifying a capacity when creating a linked blocking deck to prevent unbounded growth. Second, prefer using the blocking methods, like put and take, over the non-blocking ones, like add and remove. In concurrent scenarios, they handle full or empty conditions more gracefully. Lastly, be mindful of the iteration order. Unlike some other collections, LinkedBlockingDeque doesn't guarantee that iterator will traverse elements in any particular order.
Those are great tips, Victor. Now, as we wrap up this episode and our chapter on deques, could you summarize the key points we've covered about LinkedBlockingDeque?
Certainly. To summarize, 1. LinkedBlockingDeque is a thread-safe, double-ended queue implementation. 2. It uses a linked list structure, allowing for dynamic growth. 3. It achieves thread safety through a reentrant lock and 2 condition objects. 4. It's particularly useful for scenarios requiring addition and removal from both ends, like priority-based task scheduling. 5. While flexible, it can have higher memory overhead compared to array-based implementations. 6. Proper usage requires understanding its characteristics and potential pitfalls.
Excellent summary, Victor. Now, let's reveal the answer to our quiz question. In what scenario would you choose LinkedBlockingDeque over ArrayBlockingDeque? The answer is when you need a deque that can dynamically resize or when you frequently add and remove elements from both ends of the deque. LinkedBlockingDeque's linked structure makes it more efficient for these operations, especially when the size of the deque is unpredictable.
That's right, Sheila. The choice between LinkedBlockingDeque and ArrayBlockingDeque often comes down to the specific requirements of your application and the expected usage patterns of the deque.
Thank you, Victor, for this informative discussion. In our next episode, we'll be moving on to the exciting world of maps and sets in concurrent collections. We'll start by exploring the concurrent map interface, so don't miss it. Remember to subscribe to Java Internal's Crashcasts and leave us a rating if you're enjoying the series. Until next time, happy coding!